Constructional electrical work offers higher pay potential, variety in projects, and hands-on, active work. However, it is more physically demanding, can involve long hours and irregular work schedules, and may require travel to different job sites. Maintenance electrical work provides a more regular work schedule, is less physically demanding, and allows for specialization in specific areas such as industrial, commercial, or residential maintenance. On the other hand, it typically has lower pay potential compared to constructional work, can be repetitive and less challenging, and may involve working in hazardous environments. The traditional path to becoming an electrician is an apprenticeship program. Apprentices work under the supervision of an experienced journeyman while attending night school or technical college. This option provides on-the-job training and structured classroom instruction. A helper position is a good option if you want to gain practical experience before committing to an apprenticeship. Helpers assist journeymen on job sites, learning the basics of electrical work. Some trade schools and technical colleges offer electrical programs that can prepare you for an entry-level position as an electrician. This option is typically shorter than an apprenticeship but doesn't provide as much hands-on experience. In Pennsylvania, as a helper, you might expect to earn approximately $15 to $25 per hour. A journeyman electrician in Pennsylvania can earn approximately $35 to $55 per hour. It typically takes 4 to 5 years to become a journeyman electrician through an apprenticeship program. To establish yourself in electrical work, firstly, gain experience through an apprenticeship, helper position, or trade school. Secondly, obtain a journeyman electrician license, which is required in Pennsylvania. Thirdly, continue to develop your skills through continuing education and on-the-job training. Fourthly, consider starting your own small business if you have the experience and entrepreneurial drive. Network with other electricians and industry professionals. Join professional organizations such as the National Electrical Contractors Association, also known as NECA, or the International Brotherhood of Electrical Workers, also known as IBU. Stay up to date on the latest electrical codes and technologies. Consider pursuing specialized training in areas such as energy efficiency or renewable energy. Electrical codes are essential for safe electrical installations. The National Electrical Code, also known as NEC, is a widely adopted standard in the United States. Always refer to the latest edition of the NEC for specific requirements. Some common NEC articles and tables include Article 210. For branch circuits, Article 220. For feeder and service calculations, and Table 310.16 for conductor ampacity. Understanding Ohm's law is crucial in electrical work. Ohm's law states that voltage equals current multiplied by resistance, or volts equals amps times ohms. This law helps calculate voltage drop, current flow, and power consumption in circuits. Series circuits have components connected end to end, so the current is the same through each component. The total resistance in a series circuit is the sum of the individual resistances. Parallel circuits have components connected side by side, so the voltage is the same across each component. The total resistance in a parallel circuit is less than the smallest individual resistance. Electrical tools are essential for performing electrical work safely and efficiently. Some common electrical tools include wire strippers, pliers, screwdrivers, voltage testers, and conduit benders. Always use insulated tools to protect yourself from electric shock. Grounding is a critical safety measure in electrical systems. Grounding provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Grounding also helps to stabilize voltage and reduce electrical noise. Circuit breakers and fuses are overcurrent protection devices that protect electrical circuits from damage caused by excessive current. Circuit breakers can be reset after tripping, while fuses must be replaced. The size of the circuit breaker or fuse should be matched to the ampacity of the circuit conductors. Voltage drop is the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and reduce efficiency. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Conduit is a protective enclosure for electrical wiring. Different types of conduit include rigid metal conduit, electrical metallic tubing, also known as EMT, and flexible metal conduit. The type of conduit used depends on the application and environmental conditions. Wiring methods refer to the way electrical conductors are installed and supported. Common wiring methods include non-metallic sheath cable, also known as NM cable, and armored cable, also known as AC cable. The wiring method used depends on the application and local electrical codes. Electrical boxes are used to terminate and protect electrical wiring. Different types of electrical boxes include junction boxes, outlet boxes, and switch boxes. The size and type of electrical box used depend on the number and size of conductors it contains. Electrical symbols are used to represent electrical components on drawings and diagrams. Some common electrical symbols include those for resistors, capacitors, inductors, switches, and outlets. Understanding electrical symbols is essential for reading and interpreting electrical drawings. Electrical safety is paramount when working with electricity. Always de-energize circuits before working on them. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Follow lockout/tagout procedures to prevent accidental re-energization of circuits. Ground fault circuit interrupters, also known as GFCIs, are devices that protect against electrical shock by detecting ground faults. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, also known as FSIs, are devices that protect against electrical fires by detecting arc faults. FSIs are required in many residential circuits, such as those serving bedrooms and living rooms. Surge protectors protect electrical equipment from voltage surges caused by lightning or other sources. Surge protectors can be installed at the service entrance or at individual outlets. Electrical testing is essential for troubleshooting and maintaining electrical systems. Common electrical tests include voltage testing, continuity testing, and insulation resistance testing. Use appropriate testing equipment and follow safety procedures when performing electrical tests. Electrical maintenance involves inspecting, testing, and repairing electrical equipment to ensure its safe and reliable operation. Regular electrical maintenance can prevent equipment failures, reduce downtime, and improve safety. Energy efficiency is becoming increasingly important in electrical systems. Energy-efficient lighting, motors, and appliances can save energy and reduce costs. Consider using LED lighting, variable frequency drives, and high-efficiency motors to improve energy efficiency. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. Electrical work is required to install and maintain renewable energy systems. Consider specializing in renewable energy to expand your skills and career opportunities. The steps involved in calculating the correct wire size for a circuit. Firstly, determine the load in amps. This involves calculating the total current that the circuit will carry based on the appliances, lights, or equipment connected to it. Secondly, consider the voltage drop. Voltage drop is the reduction in voltage along the length of the wire due to its resistance. It's important to keep voltage drop within acceptable limits to ensure proper operation of the connected devices. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Thirdly, select the appropriate wire size. Use NEC Table 310.16 to determine the ampacity of different wire sizes based on the insulation type and temperature rating. Choose a wire size with an ampacity that is greater than or equal to the calculated load in amps, taking into account any directing factors for ambient temperature or the number of current carrying conductors in a raceway or cable. Ambient temperature correction factors are used to adjust the ampacity of conductors based on the ambient temperature in which they are installed. If the ambient temperature is higher than the temperature rating of the conductor, the ampacity must be derated to prevent overheating. Conduit fill refers to the percentage of the cross-sectional area of a conduit that is occupied by conductors. The NEC specifies maximum conduit fill percentages to ensure adequate ventilation and prevent overheating of conductors. Calculate the cross-sectional area of each conductor and the conduit, and then divide the total area of the conductors by the area of the conduit to determine the conduit fill percentage. Control circuits are used to control the operation of electrical equipment such as motors, lights, and heating systems. Control circuits typically use low-voltage control devices such as push buttons, relays, and timers. Understanding control circuit logic and troubleshooting techniques is essential for maintaining industrial and commercial electrical systems. Motor control circuits are used to start, stop, and protect electric motors. Motor control circuits typically include components such as motor starters, overload relays, and control transformers. Understanding motor control circuit diagrams and troubleshooting techniques is essential for maintaining motor-driven equipment. Programmable logic controllers, also known as PLC, are used to automate industrial processes. PLC are programmed using ladder logic or other programming languages. Understanding PLC programming and troubleshooting techniques is essential for maintaining automated manufacturing systems. Variable frequency drives, also known as volts, are used to control the speed of electric motors. Volts can save energy and improve process control. Understanding volt programming and troubleshooting techniques is essential for maintaining volt-driven equipment. Industrial electrical systems are typically more complex than residential electrical systems. Industrial electrical systems may include high-voltage equipment, three-phase power distribution, and complex control circuits. Safety is paramount when working on industrial electrical systems. Commercial electrical systems are used in office buildings, retail stores, and other commercial establishments. Commercial electrical systems may include lighting control systems, fire alarm systems, and security systems. Energy efficiency is important in commercial electrical systems to reduce operating costs. Residential electrical systems are used in homes and apartments. Residential electrical systems typically include lighting receptacles and appliances. Safety is important in residential electrical systems to protect occupants from electrical shock and fire hazards. Electrical codes and standards are constantly evolving. Stay up to date in the latest codes and standards by attending continuing education courses and reading industry publications. Networking with other electricians and industry professionals can help you stay informed and advance your career. Joining professional organizations such as the National Electrical Contractors Association and the International Brotherhood of Electrical Workers can provide valuable resources and networking opportunities. Consider specializing in a particular area of electrical work, such as industrial automation, renewable energy, or energy efficiency. Specializing can increase your earning potential and make you a more valuable asset to your employer or clients. Starting your own electrical business can be a rewarding but challenging endeavor. Develop a business plan, obtain the necessary licenses and insurance, and build a strong reputation for quality workmanship and customer service. Continuing education is essential for staying current with the latest electrical technologies and codes. Attend continuing education courses and workshops to expand your knowledge and skills. Obtaining certifications in specialized areas of electrical work can enhance your career prospects. Certifications demonstrate your expertise and commitment to professionalism. Mentoring is a valuable way to learn from experienced electricians and advance your career. Seek out a mentor who can provide guidance and support. Volunteering your time and expertise to community projects can be a rewarding way to give back and gain experience. Consider volunteering for organizations that provide electrical services to low-income families or non-profit organizations. Reading trade publications and websites can help you stay informed about the latest electrical technologies, codes, and industry trends. Subscribe to industry newsletters and follow relevant websites and blogs. Attending industry conferences and trade shows can provide opportunities to learn about new products and technologies, network with other professionals, and attend educational seminars. Participating in online forums and discussion groups can provide a platform for asking questions, sharing knowledge, and connecting with other electricians. Building a strong online presence can help you promote your skills and services and attract new clients. Create a professional website and use social media to showcase your work and expertise. The ability to read and interpret electrical blueprints and schematics is an essential skill for electricians. Electrical blueprints provide detailed information about the layout of electrical systems, including the location of outlets, switches, and lighting fixtures. Schematics show the connections between electrical components and devices. Electricians must be able to understand these documents to install, maintain, and troubleshoot electrical systems effectively. Electricians should understand the principles of electrical safety. Electrical safety involves identifying and mitigating hazards associated with electrical work to prevent injuries, fires, and equipment damage. It encompasses various practices, procedures, and safety devices designed to protect workers and the public from electrical hazards. Lockout/tagout procedures, also known as LOTO, are a critical safety practice used to prevent accidental energization of equipment during maintenance or repair. These procedures involve energizing the equipment, disconnecting it from its power source, and applying locks and tags to prevent it from being turned back on until the work is completed. Personal protective equipment, also known as PPE, includes items such as safety glasses, gloves, and arc flash suits that protect workers from electrical hazards. Proper selection and use of PPE are essential for minimizing the risk of injury during electrical work. Understanding the requirements for grounding and bonding electrical systems. Grounding and bonding are essential for electrical safety and proper system operation. Grounding provides a low impedance path for fault currents to return to the source, helping to trip over current protection devices and prevent electrical shock. Bonding ensures that all metallic parts of an electrical system are electrically connected, minimizing voltage differences and reducing the risk of shock. Familiarity with the different types of electrical wiring and cabling. Electricians work with various types of electrical wiring and cabling, each designed for specific applications and environments. These include non-metallic sheathed cable, armored cable, metallic conduit, and flexible metal conduit. Electricians must be familiar with the characteristics, installation requirements, and limitations of each type of wiring and cabling. The ability to troubleshoot electrical problems efficiently. Troubleshooting involves systematically identifying and resolving electrical problems using diagnostic tools, testing procedures, and knowledge of electrical systems. Electricians must be able to diagnose issues such as short circuits, open circuits, ground faults, and voltage drops. A solid understanding of the principles of electrical power distribution. Electrical power distribution involves the transmission of electrical power from the source to the load. Electricians should understand the components of a power distribution system, including transformers, switchgear, panel boards, and feeders. They should also be familiar with the different types of power distribution systems, such as radial, loop, and network systems.